Welcome members, now we are going to see how do we handle these probabilities of these cases here. But please don't forget to subscribe to the channel. So now let's go to the question because we've seen this. We have seen this formula and we have used it. So in a given district, some of 12 people was tested and a quarter of them tested positive for COVID-19. Find the probability that exactly 4 people had a positive test. So now here we need our m, so that our m is 12, the sample they used was 12. So our probability of success was those who had a positive COVID test. And it was a quarter. This sample is the same one, 0.25. So if this is our 0.25, means that our probability of failure, 1 minus this, which will be 0.75. Simple. So we have summarized the question. So part A, exactly, our part A, exactly 4 people had a positive test. Now our probability of success is the number of people that had a positive test. That's why I'm taking this with the probability of success. So this way, if you have this, you can use the formula. When use the formula, our formula is here. So our is 12, combination 4. Our probability of success into now then power 8. 12 minus 4, you get 8. I told you when you add this and this, you should get the total number. And you get your calculator and you press that value there. What I'm getting here is 0.1936 to 4 decimal places. This one I'm using method. And you have seen here we can use even a table. So now here, more than 10 had a positive test. What be more than 10? So more than 10. More than 10. And you say this one you can calculate it by saying more than 10 is the same as probability when you want x equaling to 11, more than 10, so don't include 11, plus probability when x is equaling to 12, and you press that. You come, you get your table, you can use a table or you can use a calculator, but now allow me to use a table. But remember now is that our number of trials is 12 there. So our n, we have our probability 2.5. I mean my x is equal to 11 or 2.5. They are not there. They are very, very small. They are below 1. So you can use your calculator and you put them there using the calculator. You put in this formula and use your calculator there. When I come to this, more than a half had a positive test. So in our part C, more than a half. So more than a half. What do they mean by a half? So this was, the proportion was, the sample was 12. So a half of them is 6. So more than a half. So more than a half, that's the value we have there. But we say, if you have more than a half, you can come and read it and use this. X greater or equal to this is the same as this, or you can greater or equal to. Is that more than a half, less or equal to that. So you can come and say this is the same as probability, the same as 1 minus probability when x is less or equal to now a 6, which will be 1 minus. This is the same as probability when x is 6 plus probability when x is 5 plus probability when x is 4 plus probability when x is 3 plus probability when our x is 2 plus probability when our x is 1 plus probability when our x is at 0. put that, then you get your answer here and you give it for the small braces. So that's how we handle that also. Now, what happens when we come to part D? I was interested in this part D, E, F, and D. So my part D now, they want me to get probability 1 less x less equal to 4. Now there, when I have this, the idea is very easy. What we do, this one, it means that they want above 1, above 1 we have x is equal to 2, greater than 1 plus x equal to 3, but below 4, so you shouldn't exceed a 4. That's why I'm having that. And then I can read this from individual probabilities. Our pairs is our number is 12. Then you can have x equal to 2. My x is equal to 2. Now I'm going to use a table. I have 0.2, 0.23, 23, then plus when x is 3. When x is 3, I have 0.2581. And this one, when I pull out my calculator, I'll be having 0.2. So that's why I'm having 0.4904. Now here, I'm using the table. I'm reading these values from the table. That's what I'm having there. So a moment. Okay, now members, this is the answer we got. Now, I'm going to show that you can do this alternatively. So you can say all this probability of 1 between between 1 and 4 is the same as now. This one means that you need x greater than 1. From greater than 1 means that with the closest number, the immediate number greater than 1 is 2. So x greater or equal to 2. Now, the law from 2 is going to cover many. And now you subtract off the probability when x that is then to be below 4. It means that you don't need something including 4. It means that now you subtract something that is greater or equal to 4. From there, what do we mean? It means that we'll be adding something like this. We are adding 2 and 4. So above 2, these are the values. Then you subtract off these ones above 4. You'll be adding these ones in between. From 1, above 1, then this one, so you see that the value shall get to the one which you want. The one which is between 2 and 3. So now these ones, we said you can read them from cumulative. So you go to cumulative, these are cumulative, you read this. Our pair, our was 12. So you check to cumulative, I think for now everyone knows how to read them from the table. So when I read them, I have 12. I have 12. So this cumulative, I have 12. Then, when n, 12 when x is 2, when x is 2, me here I'm having 0.8416. Then minus, and I count when x is 4. When x is 4, I have 0.3512. And when you subtract this using the calculator, the value you are going to get is 0.4. So here the value I'm getting is 0.4904. And here I indicate that I'm using a table as simple as that. Now I'm going to handle one later where we have the equal signs, then we will handle this in your free time. So when I come now to part E, part E we have probability less or equal to 5. Now this one, we said that in this one you can use the double, but now it's that this one is going to be the probability of, so we need a 2. So x equaling 2 plus, we need x equaling 3. We need also below 5. So we need, it means that we stop at x equaling 4. Now these are your videos. You come now to the probabilities of the, then you do this in the videos when x is 2. When x is 2 to the other 4. So when x is 2, here I'm having 0.2323, then plus my 3 is 0.2581, then my 4 is 0.1936, 0.1936. Then when we add this, when we add it up, and I add this, I get 0.6840. So here I've used a table to print these values, but we have seen that we can also use the formula and we read them off. And now this one, alternatively, you can say this the probability of 2, let's say equal to x, that's 5. Now you see, this time we need a 2. If we need a 2 because of this greater equal to 2, the sign means that we are going to be now greater equal to 2. So it means we are going to say for x greater or equal to, come here, so when we have an equal sign, means that we need that value. If we have an equal sign, we need that value. So that value, so it's going to be 2, because we need it greater or equal to 2, so that's from 2. Here it was greater than 1, that's why it's started from 2, and this one is greater or equal to 2. If this was greater or equal to 1, even this would be a 1. Then minus probability less than, if we have less, we have to start with this same value as we saw here. When we have less cases, we start from that value. Then minus probability of x greater or equal to this value here, which is 5. Then when we read this, now we read them from cumulative. For my cumulative now, I read x greater or equal to 2. When my pair is x greater or equal to 2. Here the value I'm having is 0.8416. 0.8416. Then minus this one. Now here we take our x to be 5. In cumulative, it's 1. 0.1576, and then you press your calculator and subtract those two things. 8416 minus 76. The answer I'm getting is 0.6840. That will be the answer. I think this is the same, but here we have used a tab. So now, I think you can actually try out this. Now this one, you see we have this way of this sign, now when it's going to be greater. So, if I'm to just give you a hint on that, for probability of 2 less x less or equal to 4, this will be now, this is greater than this, means that we are going to start from 3. So probability of x greater or equal to 3, then minus probability of x, we need less than 4. So we also need this 4 here. These are now, as I said, greater or equal to 5. Because we need a 4 because of this equal 2. And then you read those individual values there. So That's it, members. I think you have seen how we use this. I wish you well.